different rock types, different rock formations, they are presenting different strontium isotopic ratios, which basically can be transferred to the water, to the groundwater passing through those formations. So here is the strontium ratio of rocks in the United States. And on the right side, you see the groundwater data for strontium. So these are almost identical. These two maps are almost identical. And you see how the groundwater can potentially reflect the geology. The strontium isotopic ratios, along with the concentration, which can be translated to the salinity, can also provide information about the saltwater intrusion. Here is an example in South Florida. You can see the Miami, Hollywood, and Homestead. And the red zone shows the saltwater intrusion in the coastal region of the South Florida since 1995. On the left side, you see the measurements of the water from different water wells along this region. And you see the more salt water intrudes into the freshwater resources, the concentration is increased. Remember, here is 1 over strontium concentration. So the more the concentration, the lower is the number here. So here it clearly shows how the saltwater intrusion changes the isotopic composition of the strontium in the water and also the salinity and the concentration. In general, if you start off with the water sample and your water sample experience like dilution through precipitation or concentration through the evaporation, in this graph, which is the strontium isotopic ratio versus strontium concentration, your sample should move horizontally because you're only changing the concentration. However, dealing with the changing concentration along with different sources, you are introducing different sources of water to the pool, or you are adding some sort of contaminants to the water, then the isotopic signature of your water is also changing along this curve. So by analyzing strontium isotopic ratios and concentration in water samples, you should be able to understand the water circulation, the mixture of water, or the contamination in your water sources. Here's the example. These are the water samples from Denmark. At the top right, all these pink diamonds, the pristine water samples. However, in some region in Denmark, all the farmers, they are using lime to fertilize their land. So basically by adding lime to their land, they are contaminating their water resources. And by imposing that contamination, the isotopic ratios of strontium in this water is changing through these two curves. So here is another example of how people utilize the strontium isotope ratios in water to better understand the mixing and the contamination.